Hi everyone, my name is Jack Semrau and this is Lab 3 in Physics 2211. This week's lab, we observed a black hole and a star that was orbiting the black hole. The purpose of this lab was to find the mass of the black hole that is being orbited by the star. For this, we were given the mass of the star, which was 1.989 times 10 to the 30 kilograms, the black hole's position, which was -4 times 10, 0 times 10 to the 0, 0 meters. We were also given the time between each position of the star, which was 86,400 seconds. The positions of the star were given to us in a CSV file that could be accessed through Excel. My CSV file included 1,460 different positions. In this presentation, I will identify and analyze the physics I used to find the answer, but before I do that, I will set up the problem, then run the module on VPython, and analyze the answers and answer the questions provided with the lab. Let's take a look at the physics formulas I used in this lab. Here you can see velocity equaling the change in position over the change in time, momentum equaling mass times velocity, and the net force equaling the change in momentum over the change in time. I also used the other formula to find the net force, which is the sum of the parallel net force plus the perpendicular net force. The last formula we would use to find the mass of the black hole was the gravitational force between 2 points. The gravitational force between 2 points is given as the gravitational constant times the first mass times the second mass over the distance between the 2 points squared times r hat in this case. In this case, G is equal to 6.67 times 10 to the negative 11 newtons times kilogram squared over meters squared. The gravitational force is directly proportional to the product of G times m1 times m2 and is indirectly proportional to the square of the distance between the 2 points. I used and derived this formula find the formula to find m2, which is the mass of the black hole. This formula states that the magnitude of the net force times the magnitude of the distance between the two masses squared over the product of G times the mass of the star would equal the black hole's mass. Now let's take a look at the VPython code I used for this experiment. I included all the data given to us, as you can see here, here, and here. I changed these formulas to compute the new y component of the velocity. I changed the VPython code to calculate various components of this lab. Here you can see that I was able to calculate the momentum, the change in momentum, the velocity, and the change in velocity. Then I calculated dp dt, which equaled the change in momentum over the change in time, and I found that the net force equals dp dt. I then found p hat and the magnitude of dp dt in order to find dp dt parallel, which equals the magnitude of dp dt times p hat. And I've also found F-net parallel, which equals dp dt parallel. The net force perpendicular equals dp dt perpendicular, and dp dt perpendicular equals the dp dt minus dp dt parallel. I then included the function to find the mass of the black hole, as discussed earlier, and the error scale for my module. Here's my module. Now let's answer the questions provided in this lab. The first question was to analyze the difference between the net force and dp dt. The net force equals dPdt, but the net force is found through addition of total forces, while dPdt can be found through derivation and describes the motion of the star in this lab. The same goes for the perpendicular and parallel components. The second question asked whether or not it would be possible to find the new mass of a new black hole at the same location as the original black hole, but with the same path, mass of the star, and time frame as in the previous experiment. The answer to this is no, as everything would be identical. And now to conclude, the mass of the black hole came out to be 2.786 times 10 to the 31 kilograms and was found using the gravitational force equation. I hope you enjoyed this lab and tune in back next week when we analyze something new.